Now, of course, now that these databases are up and running, the operator's job is not done, right? The operator caused Kubernetes to create these pods and these containers, but then once those pods and containers came up, the operator went through the process of starting TimesTen and issuing TimesTen commands and utilities and built-ins and SQL in order to bring up those databases, right? That's something that Kubernetes itself doesn't know how to do. But having brought that up, the Kubernetes operator's job is not complete. So it is also monitoring them on an ongoing basis to make sure that that TimesTen is running successfully in those to make sure that TimesTen is running successfully in those databases, in those pods. So now we've got so now we're back out where we started. Let's look and see what's going on with that TimesTen Classic object. And as we already know, right, that they're in a very healthy state. The active database is running in demo 1-0, and the standby database is running in demo 1-1. Let's cause some mayhem, right? So, failures are a part of life, and that's there's no different here. So, let's just kill the active database, right? We're going to delete that pod. And this kind of simulates what any sort of failure might look like, whether a Kubernetes node fails or TimesTen itself fails. Things happen, right? So the active database is dead. Now, the Kubernetes operator, because it is polling and continuously monitoring the status of TimesTen in these pods, after a few seconds, it will notice that the active database is down. There you go. So it's noticed that the active database is down, and it's now in the process of failing over to the standby database. So the standby database is about to become the new active database. So that's part of the process, right? So the demo 1-0 was the active. It went down. We've failed over to the demo 1-1 database. The database that was the standby is now the active. And now there's no standby database, right? So now the TimesTen Classic object is in the state standby down. Meantime, Kubernetes itself is in the process of creating a new pod to replace the one that we deleted. And so well, as we see, it has created a new pod called demo 1-1 and added it back into the active standby pair. And the operator, once that pod came back up, that operator configured TimesTen in that pod as the new standby database. So now we still have an active and a standby. We never had any downtime, but the roles are reversed. And let's look at those events again, and we can kind of watch what happened as we go through that, as we went through that process, right? So we can see, here's where things started, right? TimesTen was normal, but then it went into this active down state, which meant that there was no active database. We made the database in the -1 pod, which was the standby. We made it the active. And then we've walked through the steps of bringing up this new demo 1-0 pod as the new standby, and now everything's back to normal. And the nice thing is now TimesTen is fully self-managing here, right? So this active standby pair will sit here and run, looking for failures, and if failures occur, reacting to them as long as you like, right? You can leave this pair of databases up for days or weeks or months or however long you would like to. And the operator will continuously monitor them, their status, report that status to you via events, and to the extent that it knows how to fix problems, it'll fix them, keep everything running for you. So that's a quick overview of the capabilities of the TimesTen Kubernetes operator. Naturally, things can be much more sophisticated than this. This was the simplest possible scenario that we could demo, but deploying databases inside of containers inside of Kubernetes is a fairly new thing. Stateful applications in Kubernetes are more challenging than stateless ones, and with the help of operators in Kubernetes, we've made this as easy as we can do it. And I hope you've enjoyed this demo. Thank you for your time.